Hi, welcome to this video. In today's video, I'm going to do a very interesting problem of Netherlands Mathematical Olympiad of 1990. The question for any integer n strictly superior than 1. We have this product as k goes from 1 to the n. We have 2k minus 1 is strictly inferior than n to the n. Okay? Go ahead, pause this video and give it a try to this problem. When you worry, come back to see the full solution. Okay, let's get started now. Okay, typically in this kind of these problems, we are using by induction as a proof. Let's claim this one is true and prove n plus 1. Okay, so let's verify the base case, which is n equal to 2, because we have n is strictly superior than 1. Okay, we have the case 1 multiplied by 3, 1 multiplied by 3 is inferior than 2 to the 2, which is true. Okay, true. Let's claim this product 2k minus 1 is strictly inferior than n to the n. Okay, is true by assumption. Okay, now we are going to prove n plus 1. Okay, so as you know, for all integer n strictly superior than 1, this implies n is strictly inferior than n plus 1. Okay, so this one equivalent n over n plus 1 to the n is strictly inferior than 1, right? So as you know, also since this one is strictly inferior than 1, that means n over n plus 1 to the n plus 1 is strictly inferior than n to the n plus 1 to the n. Okay, we always have this one. When you have something is a smaller than 1, okay, strictly inferior than 1, you have the number n plus 1 is always strictly inferior than this same number to the n. Okay, so what does mean? This implies this term is strictly inferior than 1 minus this one, right? So this term n over n plus 1 to the n minus, so this term n over n plus 1 to the n is strictly inferior than 1 minus n to the n plus 1 to the n plus 1. Okay, because both numbers are strictly inferior than 1. Also, the number which has least exponent is always greater than the number. So I'm going to bring this one to the other side. So this one equivalent n over n plus 1 to the n plus n over n plus 1 to the n plus 1 is strictly inferior than 1, right? What I'm going to do now, I'm going to take one of these numbers, n over n plus 1 to the n, and take it out as a multiplier. So I will have n over n plus 1 to the n factor 1 plus n over n plus 1. I'm going to simplify this one a little bit. So I will have n over n plus 1 to the n is multiplied. I'm going to multiply the denominator by 1. I will have n plus 1 plus this n over common denominator n plus 1. This one is a whole thing. This one is strictly inferior than 1. Okay, so this one, as you see here, n plus 1, n plus n equal to n. Okay, equal to n plus 1. Okay, so now the whole thing is strictly, the product of these two terms is strictly inferior than 1. So this one equivalent, what I'm going to do now, so this one equivalent, and this one is n to the n multiplied by 2n plus 1. So the bottom one, I will have n plus 1 to the n multiplied by n plus 1, which is n plus 1 to the n plus 1, right? Strictly inferior than 1. This one equivalent, n to the n multiplied by 2n plus 1, strictly inferior than n plus 1 to the n plus 1. Okay, so we claim this one is true. Okay, let's bring this one at the top and continue with our problem. We get to this expression. So now we already claim this one is true by induction. We claim this one is true. So since this product 2k minus 1 as k goes from 1 to the n, strictly inferior than n to the n, this equivalent, I'm going to multiply both sides by 2n plus 1. Okay, so we'll have 2n plus 1. So we already have this one now. We proved before this one. Okay, so 2n plus 1 is multiplied by this product, which is 2k minus 1 as k goes from 1 to the n, is strictly inferior than 2n plus 1 is multiplied by n to the n. Okay, so what is this? This one exactly the product of 2k minus 1 as k goes from 1 to the n plus 1, this one. Okay, so this one 2k, the product of 2k minus 1 as k goes from 1 to n plus 1, strictly inferior than 2n plus 1 is multiplied by n to the n. We proved this one before, right? This one is strictly inferior than n plus 1 to the n plus 1. Now we finish. We proved n plus 1, so that's mean our assumption is true. Okay, so I have done with this problem. Thank you for watching. I will see you in next video. Bye.